Hi, I'm Shreya. So I have got concrete sum test data set with me. I have to build regression model for that. In that, I have got one or three data points or instances and 10 attributes. There are 7 input variables and output variables in that. These are the 3 output variables and these are 7 input variables. So I have to predict these output variables from these input variables. These are 3 output variables and these are 7 input variables. I'll be deleting this number of rows, I mean this column, as I find it as noisy data for my data set. So I'll be deleting it further in my code. Coming to the coding part. So this is the code I had written. I imported these libraries and read my data file using pd.readcsv, and then I filtered my data, removing the no column from my data as I found it as noisy data for my data set. Using this command access equals to 1. Access equals to 1 removes the column and 0 removes the row, and the type gives the pandas. I'm using a pandas data frame for my data set now, and df info, df column, df index and values gives information and the column and index and values of the data frame. For building a model, initially we have to clean the data, explore the data and feature selection and splitting the data and then building a model. So for cleaning data, I had removed null values, and this is the code for that. And is null.sum is the summation of the null values. This shows there are no null values in my data set. And for describing my data frame, I use df.describe. This gives descriptive statistics for each column, and then I remove a missing value from each rows. In the shape, 1 or 3 and 10 gives 1 or 3 data entries or rows are 10 columns. And for representing my data in graphical form, I have used boxplot and histogram for graphical representation, and for data exploration, I use correlation matrix. In correlation matrix, I used Spearman method. For that, in correlation matrix, the value should be from -1 to +1. If and the positive values are directly correlated with each other. If the values are like minus and plus, then they are indirectly correlatable. Like if the slum increases and the compressive strength decreases, vice versa. And I generated heat map for that. You can see over here, and SNS spot for this data visualization. SNS is from Seaborn library, and we use it for data visualization of each variable. And later I generated a heat map for this. Here also you can see there are values from +1 to -1 or -1 to +1. I used RMSE and R2 for evaluating my predictions. And then later coming to feature selection, I consider these as input variables and these as output variables, and then I assign those to X and Y variables. Then I convert it to NumPy array. Converting our variables or data into NumPy arrays gives the best results out there, and then splitting my data into training set and test set. I split it 80% as training set and 20% as test set. I have built simple these regression models. I had done these many regression models because I want to explore, see which model fits best into my data set, and which works gives accurate results. For every model, I have fitted my data into onto the model, and I predicted R2 and RMSE scores for my data for my predictions. And then I predicted true values and predicted values, and difference between true and predicted values in training set and test set as well. And later on, I did this same thing for every model over here. Coming down, average training error and test error. I had used NP absolute df train.min. Here it gives minimum training error and test error of the model. So later on, I visualized predictions versus true values in training set and test set as well. So I did the same thing for every model over here. I used these linear regressions models, 4 or 5 linear regression models. I also that polynomial regression gives the best R2 and RMSE scores, and average train error and test error in regression models. And coming to this ridge regression and lasso regression, elastic net regression, and decision tree regression and random forest regression. Here I used these parameters for tuning purpose, and I believe max depth parameter gives tuning max depth parameter gives you best outcomes for your predictions. Here also predicted values, true values, and difference between predicted true values in training set and test set as well. So here you can see average training error and test error, and RMSE and RMSE and R2 scores, and visualization of predictions. And here also I considered these parameters in random forest regression and fitted my data onto the model, and I predicted these values. And you can also see the scores, RMS and R2 scores, and average training error and test error. The reason why I use these many models is to get to know which model works well with my data, and I'm just trying to explore. I'm new to coding, so I wanted to explore how the data exploration and how the model gets fits into the data and predicts. Thank you for this opportunity. I'm running out of the time. I have a lot to explain, but I'm running out of the time. I pasted screenshots of my code in my report writing. I'm sure you can have a look over there. Thank you, Ambi, for this opportunity. That was a great session with you. The session was very interactive and competitive as well. Thank you so much for sharing your knowledge with us. See you in college or see you in university when it after the vacation. Thank you. Bye.